Good day everyone. In indefinite integrals, you saw in the last video when the numerator is a constant, okay, and the denominator will be a root quadratic or a quadratic not factorisable. In that case, you learned we have to use completing the square method, right? Completing the square method. You learned how to do that completing the square method and how to integrate using that. So here the numerator will be a constant. Now, if the numerator is a linear means you will be having some x term and constant term or x term alone. The denominator, the same condition. It can either be a root quadratic or a quadratic which is not factorisable. Now, you are going to use a new concept. You will be writing the numerator as some a into d by dx, that is the differentiation of the quadratic plus b. This is the concept you are going to use. The numerator you will express as a into differentiation of that quadratic, the derivative of that quadratic plus some b. You will be evaluating the values of a and b by equating the coefficient of x and the constant term, and then you will proceed for the integration. This is what you are going to learn today in this video. So now let me take one example sum and then explain so that it will be easy for you to understand. Okay, let me consider the sum. I is equal to integral 2x minus 3 by x squared plus 3x minus 15 dx. You check the numerator, it is a linear. The denominator is a quadratic, not factorisable. Okay. So now the concept is, you write the numerator, that is 2x minus 3 is equal to a into d by dx of the quadratic. If you differentiate, you will be getting 2x plus 3, right? If you differentiate this quadratic, you will get 2x plus 3 plus b. Now, you have to find the values of a and b. Let us equate the coefficient of x, okay? Equate the coefficient of x and the constant term. Constant term in both the LHS as well as the RHS. The coefficient of x here is 2. That will be equal to the coefficient of x is 2a there. So you will be getting a is equal to 1. Coming to the constant term, here the constant term is minus 3. Here it is 3a plus b. Okay. Now substitute a is equal to 1. So you will be getting minus 3 is equal to 3 plus b and b is equal to minus 6. You got the values of a and b now. So let us write the numerator, that is that 2x minus 3 is equal to a, that is 1 into 2x plus 3. Because it is 1 I am not writing. If it is any other number you write it, plus b, that is minus 6. Here don't expand the bracket, you will be again getting only 2x minus 3. So you will be back to that square one, right? So don't use it. Keep it as it is. Now let us write the I, that is equal to integral 2x plus 3, write it in bracket, minus 6 by x squared plus 3x minus 15 dx. Now let us split it into two integrals. That is, you will write 2x plus 3 by x squared plus 3x minus 15 dx as one integral, minus take the 6 out, that 6 out, you will be getting dx by x squared plus 3x minus 15. Okay. So now your I is equal to, let me call this as I1 minus 6I2 So we have now split it into two integrals. This is my step 1. That is, this is my final step of answer. I will be I1 minus 6I2. Let us write it here because we need it for further reference. I is equal to I1 minus 6I2. This is the one equation. That is step 1 I have marked. Now let us move on to integrating I1 and integrating I2 separately, right? So now let us move on to the I1 part. Okay, let me write the I1 and then we can rub it. I1 is 2x plus 3 by x squared plus 3x minus 15 dx. This is the I1. So coming to the I1, you know the numerator is the exact differential of the denominator. That is how we proceeded. So now if you substitute x squared plus 3x minus 15 is equal to t. If you differentiate, what will you get? You will get 2x plus 3 dx, that is equal to dt. That is, the numerator is going to become the dt. So you will be getting your I1 is integral dt by t, which is log mod t plus c1. Let us substitute for the t. You will get log mod x squared plus 3x minus 15 plus c1. Mark this as step 2. Now let us come to I2. The I2 is integral dx by x squared plus 3x minus 15. Now the numerator is a constant, the denominator is a quadratic, not factorisable. So you have to use completing the square method. So here for completing the square method, let us write the algebra part. That is the x squared, that is the quadratic, minus 15. Okay, you know how to proceed. Divide the coefficient of x by 2, 3 by 2. Square it, you will be getting 9 by 4. So you have to add and subtract that. So you will be getting x squared plus 3x minus 15 plus 9 by 4 minus 9 by 4. Pick the x square term, x term and the positive square you have added, you know all those things. So it is x, this is 3 by 2, you have a plus here, the whole square. Now you are left with minus 15 and minus 9 by 4. 4 is the LCM. So minus 60 minus 9. So write it as root 69 by 2 the whole square. So you have done the completing the square method. Now let us come to I2. So it is dx by x plus 3 by 2 the whole square minus root 69 by 2 the whole square. This is of the format integral dx by x squared minus a squared. You know the formula? You remember? 1 by 2a log mod x minus a by x plus a. So here a is root 69 by 2. In the x place you have x plus 3 by 2. So I will be getting 1 by 2 into a. Okay? 1 by 2a log mod x, that is x plus 3 by 2 minus a, that is root 69 by 2 by x plus 3 by 2 plus root 69 by 2 plus c2. This is what I will get. Let me simplify it a bit. I will be getting this 2 and that 2 will go. So 1 by root 69 log mod, you take LCM here, not 2. Here also 2, that 2 will get cut. You will be getting now 2x plus 3 minus root 69 divided by 2x plus 3 plus root 69 plus c2. Mark this as step 3. This is your I2. Now you go to step 1. In I, you substitute this I1 answer and minus 6 into substitute this I2 answer. Then you can combine this C1 and C2. You can write with 1C, you know. So that will be the answer for this sum. So hope you understand this. Here you are splitting it into two integrals. In the first integral you are using substitution. In the second integral you are using completing the square method. Remember that. So now let me give you one more example where the denominator is a root quadratic. There let us see what is the change or what is the difference between this and that, and I will give you the hints for that. So now let me now take the sum. I is equal to integral 5x plus 3 by root of x squared plus 4x plus 10 dx. Okay, here the numerator is a linear, the denominator is a root quadratic. If the quadratic is within root, no need to check whether it is factorizable or not. It is a root quadratic. So go to the same concept. You have to write the numerator, that is equal to a into d by dx of the quadratic. Just take the quadratic, and if you differentiate, you will be getting 2x plus 4. Then plus b. Again we have to equate the coefficient of x. Okay. So now what is the coefficient of x here? 5. What is the coefficient of x here? 2a. So the a will be equal to 5 by 2. Coming to the constant term, here you are having 3. Here the constant is 4a plus b. In the place of a, you already know the value, substitute that. So 4 into 5 by 2 plus b. This you can cut. So you will be getting 10 plus b. So b will be equal to 3 minus 10. You will be getting a minus 7. So now let us come the numerator. Let me write properly. 5x plus 3 is equal to a. What is a? A is 5 by 2 into 2x plus 4 plus b is minus 7. So what happens to the I now? I is equal to integral. For the numerator you write it 5 by 2 into 2x plus 4 minus 7. Write the denominator as it is, x squared plus 4x plus 10 dx. Now we will be able to split it into two integrals. For the first integral, take the 5 by 2 out. So I is equal to, I will take the 5 by 2 out, integral 2x plus 4 you are having here by root x squared plus 4x plus 10 dx. Coming to the second part, you can take the minus 7 out. So minus 7 integral dx by root of x squared plus 4x plus 10. So you can write I is equal to 5 by 2 I1 minus 7 I2. So this will be your 1. Now you know, for the first part, it is always substitution. So here you will be substituting what is within the root, that is that x squared plus 4x plus 10 as t. Naturally the numerator will become dt. You will be getting dt by root t. Okay, root t you can write in the numerator as t power minus half, and then you integrate it. As for the second part, it is a root quadratic. Take the quadratic there. You do completing the square method, and then you will be getting any formula like root of x squared plus a square, or root of x squared minus a square, or root of a squared minus x square. Then use that formula and then you write the result. Then you come to step 1. I is equal to 5 by 2 into I1 minus I2. So since you know all those things already, I am not doing that part. So hope you understand the concept. So today what you have learned, if the numerator is a linear and the denominator is either a root quadratic or a quadratic not factorizable, you have to write the numerator is equal to a into d by dx of the quadratic plus b, and then you will have two integrals. First always substitution, second completing the square method. Just remember this, that's enough. Okay, now subscribe to the channel and then click the bell icon to get further notifications. Thank you for watching the video.